All right, welcome to the Unit 1.4a Isotopes and Ions video. So prior to taking these notes down, you should have watched a video that describes what isotopes are and one that describes what ions are. We're going to start by going over what isotopes are. I just want to note one thing that was strange in the video, or different from what we're used to seeing in the United States, is in that video and I'll just go back quickly here so you can see what I mean. In that video, the mass number and the atomic number were on the right-hand side of the nuclear notation symbol, but we put them on the left-hand side. So in that video, the mass number was here and the atomic number was down there. But just so you know, they should be on the left-hand side for us. Okay, so isotopes and ions. So you want to make sure you have your notebook, and at the top you want to write 1.4a, isotopes and ions, in your page number. Don't forget in your table of contents to be sure to include that, isotopes and ions, and the page number. And this is 1.4a. Okay, so what are isotopes? First thing, isotopes are atoms of the same element, so that means they have the same number of atomic number or number of protons, with different mass because they have different number of neutrons, so the different mass numbers. Let me make that clearer for you. Okay, so it's a different mass number. All right. Isotopes are important in nuclear chemistry, which is one of the things we'll be covering here, because the ratio of protons and neutrons determine whether an isotope is radioactive or stable. Okay, so these are some sort of background things you want to take on isotopes, and if you need to pause the video to copy this down, go ahead and do that now. Okay, so let's go over some examples of isotopes. The first three examples that we're going to look at are of isotopes of hydrogen. So what I drew on the top were Bohr models. The darker circle represents the nucleus, and inside the nucleus, the blue dot is your protons. And the circle done in pencil represents an electron shell, and there I have one electron, that's the green dot. So this first atom is hydrogen 1. And hydrogen 1, the nuclear symbol, since these are all neutral, will just have the atomic number is 1 since it's hydrogen. And since there's only a proton, there's no neutrons, the mass number would also be 1. So this is hydrogen 1. And this is called, by the way, the isotope name. And for the isotope name, you write the name of the element, and this will be the mass number of that isotope. Okay. All right, so let's look at these three isotopes of hydrogen. So we have hydrogen 1, which has a mass number of 1. Then we have hydrogen 2, which has a mass number of 2 because it has 1 proton and 1 neutron. Notice these are still both hydrogen atoms because they both have 1 proton, but their masses are different. And hydrogen 2, by the way, is known as deuterium, which has a symbol of capital D. Most isotopes don't have a special symbol, or a special name, but for hydrogen, the three different isotopes of hydrogen, they all have special names and symbols. That's kind of cool to know, but not necessary to know. Finally, the last isotope of hydrogen is hydrogen 3. It has a mass number of 3 because it has, of course, 1 proton since it's hydrogen and 2 neutrons. So total mass number is 3. And this one is known as tritium, and it has a symbol capital T. Now, these are all isotopes of hydrogen because they are the same element. This have the same atomic number, right? Each have an atomic number of 1 because they have 1 protons, and they're all hydrogen. But they have a different mass number. If you need more time to copy this down, take a moment and pause the video. Okay, let's look at some more examples of isotopes and also some non-examples of isotopes. So the next example we're going to look at is for carbon. So example B here, we have carbon 14 and carbon 12. It should be a 12, by the way. Okay. So remember, for these isotope names, that number there represents the mass number, right? Okay, so carbon 14 and carbon 12, they're both isotopes of carbon. Why? Well, they're both carbons because they have 6 protons, where atomic number is 6, and only carbon has that, so they're the same element. However, they have a different mass, so they weigh different masses. So we have carbon 14, which has a mass of about 14 AMUs, and carbon 12, which has a mass of about 12. So that makes them isotopes. They're the same element, just have different masses. On the other hand, for example C, carbon 14 and nitrogen 14 are not isotopes. And that's because they're different elements. So in order to be an isotope, you have to be the same element. Carbon and nitrogen are different elements. They have different atomic numbers, right? Different number of protons, so they cannot be isotopes. All right, if you need more time to copy this information down, pause the video. All right, last example for this section is example D, where we're talking about another case where these are not isotopes. Here we have carbon 14s. They're all carbon 14s. And the only difference is that the first one is a neutral charge, since there's no number in the upper right. The second one has a +1 charge. And the third one has a -2 charge. So these are not isotopes of carbon because they have the same mass number. They're all carbons, so they're the same element, but their mass numbers are all the same, 14, 14, 14. So if they weigh the same and they're the same element, once again, they are not isotopes. So the only way you can be an isotope is if you're the same element, but you have a different mass number. So the bottom number should be the same, so the atomic number should be the same, but the mass number on top will be different. All right, if you need more time to copy this information down, you can go ahead and pause the video. All right, so in this unit, isotopes, the information about isotopes is probably most important. But I do want to mention what ions are because it sort of helps us practice using nuclear symbols. However, we're not going to spend a lot of time on looking at ions because that's more relevant when we get to discussing chemical reactions. Okay. All right, so I'm trying to get it so you can see it here. The next section is on ions. Ion is any substance with a net or overall charge. Okay, so net or overall charge. And it can have a positive charge, that's called a cation. So for example, that carbon 14 with the +1 charge, that's an example of a cation of carbon 14. Or it can have a minus charge, a negative charge, which would be known as an anion. And that would be the carbon 14 with a -2 charge or 2 minus charge. And notice, I just want to note real quickly, I wrote that in 2 different ways. In this, up here I wrote the minus charge in front of the number, and here I wrote it after the number. By convention, the minus charge should go after the number. However, this is also acceptable. All right, so the main thing about ions is if you see something with a charge, you know it's an ion. If it has a positive or negative charge, it's an ion. And if it doesn't have a charge, if it's neutral, it's not an ion. So for example, this is not an ion. All right, that is it for this note video. If you need more time to copy down the notes, go ahead and pause and have a quality day.